All right, this is our third installment of ionic bonding. In this portion of our podcast, we're going to talk about how to name and write formulas for ionic bonds that have polyatomic ions in them. So we're going to see ionic formulas and bonds and compounds that have something called a polyatomic ion. So just like the name suggests, the word poly means many and atomic is atom. So we're going to see a group of atoms that have an overall charge and they're acting as a unit together. So this list that you have here matches what you're going to see in your guided practice. It is an extensive list. You do have to have every single formula and charge along with the name memorized. Get this done early. It's going to help you. This is where most people get tripped up when it comes to quizzes and exams, is they don't have these memorized, or they don't know the right charge, or they don't know the right subscript that's associated with it. So get those flashcards out. Get to memorizing these guys. Some of them are very similar. Let's see, nitrate and nitrite have a difference of an oxygen. You've got to get these memorized early, and I'm going to show you how we put them into a formula. So let's start by talking about how to write an ionic formula that has a polyatomic ion. So it's going to be the same rules as before. You want to make sure that the sum of your charges is equal to 0. So all the positive charges have to equal all of the negative charges. If you have more than one polyatomic ion required, you're going to put parentheses around it, and you can put a subscript outside of the parentheses. You want to kind of tend to think of your math rules for that. You want that 2 that's outside the parentheses to apply to everything inside. If you just add a 2 randomly, you're going to be insinuating that you have way too many atoms. So let's look at these 2 examples. The first one is magnesium sulfate. So I'm going to start by writing the element symbol along with the charge. Magnesium has a +2 charge because it's an alkaline earth metal, and they all have a +2 charge because they have 2 valence electrons that they donate. Sulfate, now my key here is this ATE ending. If I ever see an ATE or an ITE in a name, I can rest assured that that probably is a polyatomic ion. It's not coming off of my periodic table. So I go to my list and I find that the symbol or the group of atoms for sulfate is SO4, and it has a -2 charge. So the next step is to drop and swap. You want to make sure that you have a neutral compound. So looking at this, +2 and -2, those are equal to each other. So I need both of these in a 1-to-1 ratio. So when I write this, I need 1 magnesium for every 1 sulfate. Okay, so I write it just like that. Looking at our second example, calcium phosphate, I'm going to write the symbols with their charges. Calcium has a +2 charge, also an alkaline earth metal. Phosphate, again, I see that ATE ending, so I look on my polyatomic ion sheet and I find out that phosphate is PO4 with a 3- charge. Now, my charges are not equal. So what I'm going to do is I'm going to take those charges and I'm going to drop and swap them down to the opposite element's subscript. Okay, so calcium, I'll need 3 of those because I've brought the 3 down from phosphate, and I need 2 phosphates. Now here's the tricky thing. I need more than 1. So I need to put parentheses around phosphate before I put that 2. That 2 is saying I have 2 of everything in there, because remember, they're acting like a unit. Just for example, if I write phosphate and that I need 2 phosphates and I don't use parentheses, this is insinuating I have a phosphate with 42 oxygens, and that is not at all what I need. So make sure that you use parentheses whenever you have more than one of those polyatomic ions that's required. So we talked about how to write formulas that have polyatomic ions. Let's take a moment and talk about how to name ionic compounds that have polyatomic ions. So besides having to memorize that list of formulas, charges, and names, this is pretty easy. You're just going to, whenever you see a polyatomic ion, you're just going to give it the name that comes straight off of your polyatomic ion sheet. Sometimes you'll see hydrogen added, and it can go by 2 different names. For example, if you have a hydrogen with a carbonate polyatomic ion, that sometimes goes by the name of hydrogen carbonate, or we can see it sometimes as bicarbonate. So either name would be acceptable. A lot of our polyatomic ions end in ATE or ITE, and this is telling us which one has more oxygen and which one has fewer oxygen. So if you ever get stuck on a quiz or a test and you can't quite remember, if you remember that rule, it'll tell you which has more and which has less. And the example we used on the last slide was nitrate, which was NO3, of course now this is not writing, NO3 with a -1 charge. This is nitrate, ATE. And according to this rule, I'm told ite would have fewer oxygen, nitrite has one less oxygen, and an ITE ending. Nitrite. Oh, it's atrocious handwriting. I'm sorry, but you get the idea. So ate and ite can be clues if we get stuck. One has more, one has less oxygen. So let's go through some examples where we're starting with a formula that has a polyatomic ion and we're converting it to its name. This can be tricky. The way I know I have a polyatomic ion by looking at the formula is if I have more than 2 capital letters. So here I have 1, 2, 3 capital letters. That tells me that somewhere in there, 2 of those 3 are a polyatomic ion. So I know, because I memorized my list, that SO4 is a polyatomic ion. So I'm going to label this as a hydrogen. I don't change that at all. Hydrogen is my H, and then I'm going to name this polyatomic ion straight from the list. I look at my list. SO4 is sulfate. So the name for H2SO4 is hydrogen sulfate. Can also go by the name bisulfate. All right, for the next one, I see one. Let's do a different color. I see 1, 2, 3 capital letters, so that tells me that I'm going to have a polyatomic ion, and thankfully this one is in parentheses. Notice that I have actually 3 hydroxides for every single aluminum. That is outside the parentheses anytime you have more than one, so that we're not saying that, you know, it's an oxygen with 3 hydrogens on it. So it's very important you remember the parentheses when you have more than one. All right, so we name the metal as is. It's nothing special. Sorry, aluminum. And then I'm going to look on my list. OH is the polyatomic ion called hydroxide. I don't need to change anything about the name. I just name it as is right off the sheet. So we have aluminum hydroxide.